Hey everyone, welcome to day 10 of Math 133. Today we're going to be going over the Chapter 4, Project 2. Uh, don't forget to also do the 5.3 lecture notes. They're due on Thursday, but if you can do them before tomorrow, Elaine and Cindy are going to use that information to work on worksheets in tomorrow in the Wednesday class. Okay. All right, so today is the chapter 4, project number 2. We're going to look at everyone's arm lengths and heights. So back here on day 8, you're supposed to fill out the survey. If you haven't filled that out yet, I'm not going to be able to accept that one late because we're going to need those numbers for tonight. But anyway, so I've got that data collected and we can use it in our project today. So most of the projects are going to be looking at real world data, and in this case, it's our data, it's our class. So yeah, we'll see how that goes. So um, coming up on October 16th is the midterm. So that's Thursday, and we're going to be starting. If you're taking it with me in Zoom, we're going to be starting the midterm at 6 o'clock and we're going to go until 9. Okay, so normally we start at 6:30, go until 8. The midterm will start at 6 and we'll go until 9. So you have 3 hours. Um, Last year, I think the longest anyone took was 2.5. But if you are feeling uncomfortable, you're not sure if you're going to have enough time to do everything, that's okay. You can also take the test at the testing center. Okay. So you can take the test at you can take the midterm at the testing center Tuesday through Friday that week. So October 14, 15, 16, and October 17th. Okay. If you are going to take it on Friday the 17th, you're probably going to want to give them set up an appointment with them. Okay. Because on Friday, October 17th, Fridays, they're not open as long as they are the rest of the week. Okay. But make sure you have that time set aside to take the midterm. Okay. Um, for the midterm, we're going to be talking more about it as it gets a little closer. Okay. But for the midterm, you're going to be able to bring your yellow exam notes packet. That's the packet in your course pack that's yellow. Okay. Starts on page 255 or 253, I believe. Okay. You're also going to be able to bring a 8.5 by 11 piece of paper, front and back, with whatever you want written on it. Okay. Um, I believe you are allowed to bring your laptop, but you might want to double check with the testing center on that. If you bring your laptop and they say, hey, you can't bring that in, that's okay. You can just use the computers there. Make sure you have your password and your username for Pearson for StatCrunch. Okay. For those of you who are having some issues getting into StatCrunch, you're going to definitely want to have those resolved by the time you take the midterm. Okay. Um, all right. So, uh, also coming up on October 14th, we're supposed to be covering the sample midterm exam, but we are not going to have any class that day. It's not great timing, but that Tuesday, there's not going to be any classes. So we are instead going to be covering the sample midterm uh, throughout the next couple of days. So this Thursday, we're going to look at Chapter 5 review, and then we'll also look at a little bit of the sample midterm, okay? And then same thing on Tuesday and Thursday next week, okay? And any parts that we don't get to cover, Cindy and Elaine will get a chance to cover the sample midterm in their classes. So we'll hopefully get a chance to look at all of it, okay? So it's still going to be due October 16th. We're just not going to be able to cover in class on October 14th. Okay.
Is that the
Uh,
pathways? Is that the pathways day, Joe? What they
Indeed, it
call that?
is.
Yeah.
Yeah,
Yeah.
this year they schedule it in the middle of October, and I'm not the only teacher having midterms that week. So it's yeah, terrible timing, but
Terrible
you know,
timing.
we'll work around it. So um, okay, so today though, we're going to be looking at Chapter 4, Project 2. So if you click on that in Canvas, There are two links in here that we're going to need. All of our projects, most of our projects are going to be Google Documents or StatCrunch stuff. So uh, I guess there are some in the course pack, but today's is going to be at a Google document. So you're going to click on this link, and this will take you to the Google document. We're going to fill out all of our answers. Okay. So I'll drop this in the chat for us. And you're going to need to go to File, make a copy. Okay. And you can save it wherever you like. You can save it in My Drive. You can, if you've got a folder going. So I have a fall 2025 folder, but I'll put it in My Drive and make a copy. All right. That way we can edit this guy. Okay. All right. So what we're going to be doing is examining the relationship between arm length and height. So both of those are quantitative values. They're numbers that you can measure, okay? And you can do subtraction, you can do math on those. Um, so we're going to be creating a least squares linear relationship between the two and seeing if there is a relationship. So do people who are taller have longer arms? Are people that are shorter, do they have shorter arms? Okay. Um, so we have a data set in StatCrunch that I've collected, and it is back here in Canvas. The link is right here. And I will also drop this link in the chat for you. There we go. And let me know if you have any issues getting to that. Make sure you sign into StatCrunch. But let me know if you have any problems getting to that. Okay. This is the results of our survey. And I did put, so I took everyone's email out, but I did leave everyone's name in here. So if you do have any issues with people seeing your name and your height, this is shared with everybody. So let me know and we can take you out. Um, yeah, I'm pretty sure the length of your forearm and your height are not PII, personally identifiable information. But again, if you're sensitive about it, let me know and I'll take it out. Um, okay, but this, by the way, this is everybody who's taking Math 133. So this is not just our class, but that's fine. Okay. Um, all right. So now that we've got that, let's take a look at what we're doing. So uh, create a scatter diagram of the paired data using arm length as the explanatory variable. So arm length will be X. Okay. So we do graph and then scatter plot. So you're going to hover over graph. Oh, before I go on, was everyone able to get into this document? This morning I had some errors and I had to change my sharing. So I got one thumbs up. So I got two. All right. So we're in. So we're going to go to graph and then we're going to go down here to scatter plot. Oh, 1 second. Sorry about that, everybody. My daughter was asking questions. So, okay, where were we? So we were going to do graph and then scatter plot here. The X variable is going to be forearm, but so the label on here is what is the length of your inner forearm to the nearest centimeter, blah, 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 blah. So I'm gonna change that because that's annoying. So let me just change this to forearm. We can change it to forearm length or just forearm. And then this one is height. I should probably change these to last name and first name as well, but that's okay. I don't need those. So all right, so I'm going to change those just so that way when I do my graph and my scatter plot, my X variables actually are a little nicer, my labels. So X variable is forearm, Y variable is my height, and I'll hit compute. Okay. Yeah. This is a crazy looking graph. So it, if I had to draw a line through these dots, I would probably draw it right here. So it looks like these are in a straight line. Okay. Um, but I have one dot that's hanging out way over here to the right, okay? And um and that's because I have this outlier, okay? So that kind of thing happens when we talk about real world data, okay? So in our class, um the data that we give, so the data that Cindy and I give for like the worksheets and stuff, sometimes it has outliers, and we've talked about outliers, but mostly we've cleaned up the data, okay? And as a data analyst, when you are working with a new data set, there's always weird things in the data, okay? Our data is never going to be 100% accurate because it's created by humans, okay? And so we have to learn how to deal with those outliers, especially since uh, if we did try to do our linear regression right now, it's not going to draw the line right here like we would like it to. I'll show you what it looks like. So you don't need to do this part yet. So this is what it's going to look like though if we were to go on with the data as is. We would get our line looking like this, okay? Where it's definitely going through the middle of our data, but it's not drawing the line like we expect it to. It's trying to put the line close to that outlier. So I guess it's kind of close to that outlier, but that linear regression has a terrible correlation coefficient. It's very close to zero. And we've seen before that if your correlation coefficient is close to zero, there's no relationship. Okay. I can definitely see that there's kind of a line here. So I would think that I should have a better correlation coefficient than, you know, 0.07. Okay. So what I'm going to do is I'm going to find, oh, I wanted to find that outlier. So this outlier right here, if I hover over it, is a height of 154 centimeters and a forearm length of 243. So so someone's forearms are longer than they are tall. Um, so this is again, this is probably not a legitimate outlier. This is probably an error. Okay. Whenever we have outliers, we need to talk about how to handle them. Okay. Because we've seen that least squares regression, linear regression, is not resistant outliers. It is very heavily affected by outliers. So we need to be able to handle those. Okay. And sometimes the right answer is just throwing that data out. Sometimes the right answer is going back and, remeasuring it or just correcting it, uh, trying to correct it ourselves. Sometimes the answer is nope, you have to deal with it. That outlier is accurate. Okay. So anyway, let's scroll to the bottom of our data set because it's down here at the bottom. This guy right here. And again, so we're not trying to call anyone out. Looks like Courtney, if you put this one in, don't worry about it. You still got your full 10 points for filling out the survey. Okay. This kind of stuff happens whenever you're dealing with data, especially when you're dealing with data that's entered by people. Humans, we make mistakes. Okay. And even if this was run through AI is not necessarily going to know how to handle this. Okay. So we always are going to need, people to be able to, look at this and make sure that things are correct. So it appears to me that all of these forearm lengths are like 28, 23, 18. I think what happened is when Courtney did her math from inches to centimeters, she missed a decimal and it was actually supposed to be 24.38. Okay. So that's what I'm going to put in here. I'm going to put in 24.38. I'm just going to correct this. Now, as I said, sometimes the right answer is we need to go back to Courtney and ask her to remeasure. Okay. Or maybe the right answer is to completely throw this one out. Okay. We just don't trust that data. So I think her height, though, 154, seems in the ballpark of these numbers. So I think that one is fine. Okay. Um, so if I was to regraph this now, let's go to graph and scatter plot. X-axis is forearm, y-axis is height. That looks a little less, looks a little better in my opinion. Okay. It's still kind of spread around. Okay. And I still do have an outlier here. This one hanging out over here is a height of 152 and a forearm of 6. So a forearm of 6 centimeters is about 2 inches. Okay. And that's certainly possible. I mean, they could have some kind of dwarfism, but the height is still 152, so that doesn't seem like that would match up with someone like that. So that one is the last one. And again, if this is you, I'm not calling anyone out. If Ariel filled this out the survey, which she did, she got the full 10 points for that part of the project. Okay. So if I was to do the linear regression on this one, let me see what it looks like here. Linear regression. And again, you guys don't need to do any of this. I just want to see what it's going to look like. So our regression correlation coefficient now is 0.52. So that's way better than it was. Um, and you can see that that one is still a bit off of the line. It still looks like an outlier. So I am going to try to correct that one as well. Um, so let's see. So in Desmos, what is 6 inches times 2.54 centimeters in an inch? 15.24. So that might be what it is. Actually, you know what? It might be that she meant to write 16 and just put 6. So in that case, I'm not sure if it's 15.2 or if it's 16. Um, but again, as I've said before, our data is never going to be 100% accurate. So I'm going to put it in as 16. Okay. And, you know, if we have those two errors out of 166 people, I'm pretty good with that. Okay. I've said before, and you know, whenever you're dealing with data, your data is never going to be 100% accurate. And you know, you tell that to a CEO, and they're going to be very mad. They're going to be like, "Why is our data not perfectly accurate?" Well, it's because you hired humans. So, uh, but usually you can make the right business decision even if your data is 90% accurate or 95%. Okay. And 95% is kind of the target. We're going to be talking about 95%, especially when we get to chapter 9. Uh, when we start talking about confidence intervals in chapter 10, when we start doing hypothesis testing, 95% is going to come up a lot. We've said 95% a few times already, right? If something is less than 5%, then we call it unusual. Okay. So if it's in the 95% range, it's usual and it's good enough. Okay. So anyway, with that said, so I'm going to make those two changes to this one and this one, and I'll do my graph, I'll do my scatter plot, and we'll leave it at that. Okay. So now let's actually answer some of these questions. Um, so here's my scatter plot, and I'm gonna grab a screenshot of that here. Okay, and then the other option is you can do options, copy, and then right click and copy that image. Okay, and we'll paste that into our question number 1 here. Okay. Create a scatter diagram of the paired data using arm length as explanatory variable. So for arm length is my x-axis. Here's my y-axis. Okay. Um, Do you have to change the mistake data? So no, you do not have to change the mistake data. I would recommend it, but that's okay if you don't. Your numbers are going to be a little bit different from mine, which we've done before, right? In all of our projects, your numbers are not going to match up with mine, right? The projects give you a chance to work with real world data and get to work with your data. There's actually going to be a project that we're going to be working on in October about candy. It might be in November, but anyway, so everyone's going to have to go out and buy some candy and count how many colors you have of each one, and your numbers are going to be different from mine because you're going to get a different bag of candy than I am. Okay, so your numbers do not have to match mine. So if you want to use the one where uh, you correct this one, the 243, it'll look like you have one outlier that's off by a little bit. If you change both of them, that's fine. If you don't change either of them, I'm fine with that too. Okay. Um, yeah, so it's up to you, Nina, if you want to change those data or not. Because like I said before, sometimes the correct answer is that you have to work with that outlier because it's a legitimate outlier. Okay. Or it's a legitimate measurement. So it's accurate. So okay, so let's move on to the next question. Question number one was just grab a scatter plot and do that. Judging just from the scatter diagram, what type of linear relationship appears to exist between the data? Strong positive, strong negative, moderate positive, moderate negative. Okay, so with my data, if I try to draw a line through this, it looks to me like that line is going upward. Okay. There's no data up here in this corner. There's not much data down here in this corner. If I had to draw a line through the middle of this, I would draw it right here. Okay. So that's going to be a positive slope. And that should make sense because as your height increases, taller people we would expect to have longer forearms. Okay. So I'm going to say that that's a positive direction. Now, do you think that that would be a strong relationship where they're all kind of lined up, or moderate, or weak? No
Moderate.
relationship. Moderate. Okay, I'm good with that, Kara. No relationship would mean like the dots are very spread out, which I can kind of see they're pretty spread out here. So are you? Yeah, it's either moderate or weak. So Kara thinks it's moderate. What do you guys think? Do another vote? I got another moderate. Okay, we'll go with moderate. Okay. I think it's moderate. Yeah. So, and again, like I've said before, today's not test day. So don't ever feel like, if everyone's like, it's moderate, it's moderate, it's moderate, and you're like, I think it's weak. That's okay. It's okay if you're wrong, especially, if you speak up and you're like, I think it's a weak relationship, and then you end up being right, you can be like, ha, I got it right. So anyway, all right. So we're gonna say it's moderate positive for number two. That's going to be our guess. All right, using StatCrunch, conduct a simple linear regression on our data set, gathering both the output and the scatter diagram. So the output's going to be the numbers and the scatter diagram with a regression line drawn. Okay, so there's two parts here, but it's only going to take one step. We do regression, stat, regression, simple linear. Let's come back over here and do stat, regression, simple linear. Okay, stat, regression, simple linear. Our x-axis is forearm length, and our y-axis will be height. And I'll hit compute. So the output numbers that I want are all right here. Okay, I've got my slope, I got my intercept, I've got my correlation coefficient, everything here. So it looks like this correlation coefficient was 0.53. So Nina, going back to your question, do I need to adjust that 6? Well, when we didn't adjust it, it was 0.52. So fixing that outlier didn't really help us much, okay? Fixing the other outlier really did. That outlier was a little farther off. So so going to back to your question, do I need to fix the outliers? No, not necessarily. 0.53 or 0.52. It's not much of a difference. So I can grab that, or you can just uh, select everything like this. Just click and drag and select all of the letters and words here, and then copy that over here. Okay. And then we also want to paste the graph. So if you go to StatCrunch, down here in the lower right-hand corner, there's an arrow, and you click on that, it'll show you the scatter plot, this time with the line drawn through it. Okay, so I need to grab that as well.
This is also what you got me.
Sorry, what was that? Okay. All right, and I'll paste that graph right here. There we go. Oh, I cut off my x-axis. Well, that's no good. That's what happens when you use snipping tool sometimes. There we go. That's better. That looks better. And again, slow me down if I'm going too fast. If you have any questions on anything, let me know. So if you're like, wait, how did I get to the dots with the line? I can show you. Okay.
Yeah, actually, could you please go through that one more time?
Yeah, absolutely. So what I did was I went to graph. Nope, that's for graphing the scatter plot. I don't want the scatter plot. I want the regression. So stat, regression, simple linear. And that's what it says at the top of page 255, all the chapter 4 stuff, stat, regression, simple linear. And then I selected my x-axis and my y-axis, and I hit compute. So that's going to give you all these numbers, and you'll need to paste those into the Google document, but you also need to paste the graph, and you'll find the graph in the lower right-hand corner. There's a little arrow, and if you click on that, it'll take you here, okay?
That's what I missed. Just the little arrow. Thank you, Joe.
And yeah, and you can flip back and forth between them, so. All right, so let's jump back to here. All right, so yeah, make sure you paste both the output and the dots down here. Okay. All right. State the value of the linear correlation coefficient for these data. Okay, so correlation coefficient was this one, 0.53, 0.537, 0.537. We'll do 3 digits. Okay. Does the value from number 4 support or contradict the strength and direction of the data from number 2? So number 2 we said was moderate positive, so 0.53, according to page 255, we have the number line here, and it looks like it does fall into the moderate positive. So 0.5 is the cutoff, so we're just barely in the moderate, but I would say yes. Yes. Um, 0.537 is a moderate positive correlation. Okay. All right. Number 6, state the value of the coefficient of determination for these data. So coefficient of determination is right here. It's R squared. So 0.288. 0.288. Now, keep in mind, that's mine, and that's based on data that where I went in and I fixed 2 of the outliers. Your numbers might be different, okay? So make sure you fill in your R squared, okay? If you didn't make the same adjustments that I made, okay? And you don't need to, okay? Your R squared is just as good, okay? All right. Interpret the value from number 6. Oh, so going back here, yeah, okay. Yeah. Interpret the value from number 6 using the context of the situation. So at the bottom of page 255, there's a script for the coefficient of determination. First, you take that number and you switch it to a percent, 2.8%, and then you say of the total variation in, then you write out what y is. Y in this case is height, is explained by the least squares regression line. Mhm. So 28% accurate. That's less accurate than I would have thought. I would think that, if someone is tall, they have long arms. If someone's short, they have short arms. And I guess that's moderately true, but we don't have a strong relationship. We do have quite a few outliers here. So, or maybe not necessarily outliers, but people who are a little farther off the line. So interesting. All right. Number 8, state the equation of the least squares regression line. All right. So the equation is right here. Okay. So let me see if I can get this on the same screen. There we go. That'll work. All right. Oh, nope. I have it. I have them flipped, don't I? Ah, nope, I don't want that. I want this. There we go. That's what I wanted. All right, number 8. So my equation is y equals 126.50 plus 1.78x. So it's this one right here. Height equals my y-intercept plus my slope times my x. Um, Now, if you didn't change them to if you didn't change the names to the labels to height and forearm, that's fine. You can use right here where it says the intercept and the slope and fill it in that way. That's totally fine. Um, so this is my equation. And usually I like to put my slope and my x first. So you could flip it around and write y equals 1.78x plus 126. Either way is fine. You don't have to flip them. It's just, I just like it that way. But this, by the way, this is actually y hat. This is not necessarily y. The difference is that y hat is a prediction. It's an approximation. So the line is predicting where people are, is predicting people's heights. Okay. Is it their actual height? It is not. Okay. So there are some people who are on the line, but there's also quite a few people who are off of the line. Okay. So that's what we'll be talking about in the next couple of questions. Okay. State the value of the slope. So my slope is 1.78. And interpret the value of the slope of the regression line in the context of the situation. Make sure you include units. So there's an interpretation in the middle of page 255 that goes, if x increases by 1 unit, and in this case, my units are centimeters, then y, height, is expected to increase or decrease. So that depends on the slope. And in this case, my slope is positive. So I'm going to say increase by approximately. And then you write out the slope. And if it's a negative, you just drop the negative and you just write out the number part of the slope. And don't forget you need units. So those are height was also measured in centimeters. So if forearm length increases by 1 centimeter, then height is expected to increase by 1.78 centimeters, okay? State the y-intercept. Y-intercept is 0, 126.50, okay? Explain why the y-intercept does not make sense in the context of the situation. So 126 is the height, and I guess you can have someone who's very short and that height makes sense. Usually it's the 0 that doesn't make sense. So impossible for a person to have a forearm that's 0 centimeters long, okay? 0 centimeter forearm would mean your arms are attached to your elbows. Okay, so unless you had some kind of surgery. Yeah, so Jake was pointing out, what if you were an amputee? So if that's the case, yeah, he's in nursing. So if that's the case, then your our prediction is going to be pretty bad, right? So if someone had a 0 centimeter long forearm, then our prediction is that they would be 126 centimeters tall. And if that's the case, then well, just because your arm was amputated doesn't mean you suddenly became shorter. So um, yeah, so I guess it's not impossible, but it doesn't make sense because like I said, even if it was 0, your height wouldn't be that. Your height would be your normal height. What value did you get as your forearm length? Oh, okay. So, uh, that's the reason why I left everyone's names in here. Again, if you want your name removed, I'm totally fine with that. Let me know and I'll take it out. But I left people's names in there so that you could easily find yours and then enter what it is. So I don't know. I'll just make a guess on mine. 25, I guess. Um, yeah, I probably should have measured mine before before the class. So, by the way, you'll notice that our our data here has a couple weird things. Like, you notice how like all of these dots are lined up, and then all of these dots are lined up vertically. So you can kind of see some patterns in there. What's happening there is some people measured their exact centimeters. So this is 23 centimeters, maybe 22, 23, 24. Here's 25. Some people, on the other hand, did measure with decimals. And so this one was like 22.86. Okay. So did you need to measure it exact or did you need to measure it with decimals? Again, as I said before, your data is not going to be 100% accurate. We didn't give you any rules on does it need to be to the nearest centimeter or does it need to have decimals, in which case you'd be measuring to the nearest like millimeter. So sometimes you have to work with the data you have, okay? And this is the data we have. So we could go in and round it, but that's actually probably going to make it less accurate, okay, than what we have now. So forearm length is technically continuous, so you are allowed to have decimals, but when you're measuring it, sometimes it's easier just to round, right? So, okay, use the regression equation to find your predicted height based on your forearm length. Okay, make sure you show units. Okay, so the equation of the line is this guy right here. And I'm going to say, so my forearm length was 25 centimeters. Now, was that a Y value or an X value?
X value?
That is an X value. That's right. So my equation is 126.5 plus 1.78 times 25. Okay. All right. So let's see what Desmos says about this. 171 on the nose. All right. 171 centimeters tall. Okay. So that is my predicted height. Okay. Calculate your residual. So the residual equation is at the bottom of page 255, and it goes like this. Residual equals your actual height minus, where's my minus key? Your predicted height. Okay. So in this case, my actual height is, well, let me see here. Let me pull my calculator and figure that out real quick here. 6, 7. Whoops, lost it. So my predicted height or my actual height is 173 minus all right, so my predicted height was 171 So your actual is going to be the one that you measured from the survey. Okay, so go find that. And then your predicted is going to be the answer from number 14. Okay. Oh, no, I did my math wrong. Shoot. All right, 163. Yeah. Sorry about that. Okay. So in Desmos, how much is this? -8. Okay. And yours residual can be negative. Okay. That's fine. Make sure we put our units in. Centimeters. Okay. All right. Were you taller or shorter than predicted? So the line, the equation predicted that I was going to be 171, but I'm actually 163. So I am shorter than predicted because my residual is negative. Okay. Or the opposite would be I'm taller than predicted because my residual is positive. So depending on whether you got a positive or negative number for number 15. All right. Use the regression equation to predict the arm length of Andre the Giant. Was 223 centimeters. Show your work, give 3 decimal places, and include units. Okay. Um, so I'm going to grab the equation of my line again. So if you haven't heard of Andre the Giant, that's okay. He was a wrestler. He was in Princess Bride. So if you haven't seen that, that's definitely a good movie to watch. But he was a wrestler that he fought against Hulk Hogan when he was and lost to Hulk Hogan back before Hulk Hogan was famous. Although I guess you guys don't might not know who he is either. So anyway, okay, so 223 centimeters tall. Is that a uh, X value or a Y value?
Y value.
That's a Y value. Yep. So whenever you're plugging numbers into the equations here, you got to make sure you pay attention to which spot you're plugging them in. Okay. So 1.78, and we need to find our X in this case. Okay. All right. So to solve this, we first start by subtracting 126 from both sides. Okay. So 223.5 minus 1, what was it again? 126.5. That gives me 97. So if I subtract 126 from both sides, I get this. Okay. And then we'll divide both sides by 1.78. And we get 54.494 centimeters. Okay. So we predict that his forearm was 54 centimeters long. Okay. All right. Explain why the value for number 17 is outside the scope of our model. Okay, so if we go back to our data set, do you see anyone in here whose height is around 223 centimeters? So we've got one here that's at 198. That's the highest one. But 223 is even higher than that. Okay. Also, this one isn't even close to a 54 forearm length. So our answer is that 54.494 is, oh, wait, hold on. Let's write it out as, let's write it out like this. None of the students measured and a forearm close to 54.494 centimeters. Okay. So nobody in the class was even close to that measurement. So that means that that measurement is outside the scope of our model, which means that our linear regression is not going to be especially accurate there. Okay. Our prediction is it's going to be pretty far off. Okay. Um, anyway, yeah, that's it. That's all we have for the project today. So make sure you click on share in the upper right, change your restriction, make sure it's anyone with the link. We'll copy that link over here into our project for Canvas. Paste that here. And we'll hit submit assignment. And we get our confetti. All right. All right, so that's all I have for you today. So if you have questions, feel free to stick around. If you missed any part, let me know and I can help you out. We'll be talking about the midterm this upcoming Thursday and starting the sample midterm. So that's definitely a good one to be there for. I recorded the entire session today, so if you need to go back and rewatch it, you can. But otherwise, I will see you on Thursday and Cindy will see you tomorrow.